go through a discussion of supply chain, a little less technical than we had before, but we think a topic that's becoming increasingly important throughout the industry. I'm Mark Sherman. I'm from the Software Engineering Institute. For those of you who are not familiar with it, that is a DoD-sponsored research center at Carnegie Mellon University. We've got about 700 people there, of which about 70% are the technical folks doing technical research, and about 2/3 of those do work in cybersecurity. So we have several hundred, many hundreds of people actually focused on doing cybersecurity. And the briefing that I'm going to give you today is very similar to ones that we've done in an attempt to evangelize the topic in lots of other places. Another version of this, for example, was briefed to Congress at the Committee of Energy and Communications last week. So even they are willing to take time out of the other things that are going on down in DC in order to learn more about this particular area. Now, we view supply chain as part of the larger question of how you build secure software. And for those here at Microsoft, you know that there's been a lot of work that Microsoft has done in this area as well. We also view it as a life cycle issue. This is simply a framework in which to talk about it, requirements, building, and operations and maintenance. There are some things that cross the whole life cycle, such as how you automate all these processes, how you measure, how you educate people in the right way. But the particular topic today is procurement or acquisition. That's usually what we say when we're talking to the federal government. Most other people call it supply chain. Or more simply, throughout the entire development process when you're building software, you're making buy or build decisions, whether it's for requirements or pieces of components or whole subsystems. You frequently have the choice, do I build it or do I go out and source it from some other place? Now, when you talk about supply chain, when most people think, they think in terms of counterfeits. Getting a fake purse or a Rolex watch that's not really a Rolex watch at your favorite place or on eBay or what have you. You do similar kinds of things with electronics, so whether it's fake ink or even Cisco router cards. That really is true. The counterfeits is a problem. That's not quite really about supply chain. The Rolex company, to the best of my knowledge, plays no part whatsoever in those Rolexes that you can buy in Times Square on the street. They don't, other than perhaps an inspiration, they don't participate at all. And so there's not really an interruption of the supply chain itself. Really, what a supply chain does is make sure that from one end to the other end, from creation until final consumption, that you maintain some sort of properties. And one example that's used a lot is something called the cold chain. So pretend that you're picking lettuce. As the lettuce gets picked, it gets refrigerated so it stays fresh. It stays cold and fresh as it goes into the warehouse, into the trucks that take it to the grocery store, and finally into the store itself. And then you put it in your car that's overheated and it wilts anyway. But the supply chain itself tried to maintain those particular properties. And there's a variety of these kinds of things. In the legal system, there's chain of custody, for example. In the pharmaceutical industry, there's, again, various kinds of supply chain guarantees to make sure there's no adulteration of product as it moves throughout the supply chain. However, there's even a higher level concept that applies, I believe, in more software, something called the value chain. When we're talking about the lettuce, pretty much the head of lettuce that came off the field is the same head of lettuce that you get out of the store. But for example, you can talk about, in this case, oranges. From oranges, you then can sort the oranges into by size or whether they're good or not. You can convert it into juice. The juice itself can be bottled. The bottled juice can actually be made into a drink. Each step along the way has added value into it, so that not only are you moving it from original development to consumption, but you're also adding things to it as well. The guy who talked about this is someone named Porter, and among the other comments he observed or made was that as you're doing these changes, you also have the entire process that's making the changes. So again, let's talk about simply in physical terms, because it's easier to start with that kind of idea. You've all seen things that you buy in the store that says, made on equipment that may have had shellfish on it, or may contain peanuts or things of that sort. It's the tooling as well. So it's not simply the oranges that it's making into orange juice, but maybe there's some trace peanuts that got in there as well because the tooling, the bottling that was used, I'm not sure exactly how, but included some sort of peanut stuff as well, and therefore the tooling affected what the value chain was as it goes throughout the organization. Okay, what's that got to do with software? Well, I'm going to take you through a very fast evolution of software. Some of this may predate the vast majority of the people in this room, kind of looking around the room here or not. But I'll use my sister as an example, so she's about my age, so you can kind of guess that vintage. In the beginning, software was all custom built. Every company built their own software. So again, my sister, she worked at a Fortune 500 glass company. She was a programmer there. What did she do? She built an airline reservation system for their corporate jets. Now, is that something that a glass company really ought to be doing? Well, at the time this was happening, that in fact is what she did. Is there a supply chain going back to the lettuce? Well, no. The person walked down the hall to her office and said, I wanted to do this. Well, after a while, the glass company and many other companies realized that they really weren't in the business of doing airline reservations. They're in the building of making bottles, or saying more practically, general ledger packages, to that sort. And so you start to see the rise of the ISV, the independent software vendor, people who build applications who amortize the cost of that application across all the people who want it. Everybody needed a general accounting package. No reason for a glass company and a steel company to each build their own kind of package. In this case, again, my sister's career, she joined a company that builds systems to manage wiring harnesses. So Ford and BMW and everyone has wiring harnesses. Rather than writing their own software to manage it, they went to this company that she worked at. But what's happened since then? Now we come to more what's happening today. Today, development really is about assembly. That's because the products are usually too big. There's usually too much specialization in some of the individual components. And many times there's not a whole lot of value in the little pieces of components. Give you, again, another history lesson. Way back, a couple years ago, people used to sell TCP/IP packages as several separate pieces of software that you could go out and buy. I don't think you'll see anywhere a place that you can go buy a TCP/IP package. It's just not worth it to go develop that kind of thing and try to sell it as a separate component. But now your supply chain starts to turn long. In this made-up example where General Ledger has an application server in it and a database in it, I picked random company names here, product names, just to make it more concrete. I'm not endorsing or saying anything about WebSphere or SQL Server or Oracle or what have you, right? So what does this actually look like in practice? This is sort of an abstract kind of view. Let's take some examples. Well, you get a very broad tree of what's going on. So it's not even a value chain, it's a value tree. Take a look at Apache, just as one example. Let's look how branchy that tree is, how wide that tree is. In this case, this is just the first level down of the different pieces that go into Apache. There's over 80 different pieces. So that's really quite a big fan out. How about going down? Well, let's say you started with an application server. Oracle has one, IBM has one, Red Hat has one. I mean, there are lots of them out there that you can look at. SAP has one. They start with an application server, but inside of it, there's usually an HTTP server, another component they got from someplace else. In fact, in that particular case, those companies usually work together on some open source version. Again, it's just not make sense for them to individually invest in it. It's not worth that much to them to differentiate. But that itself has an XML parser inside of it. And where that XML parser come from? It came from the use of C libraries, which in turn were compiled by a C compiler, which in turn has a generated parser in it, another piece of a component, which in turn came from a parser generator, which in turn got compiled by another C compiler. So if you start looking at it, you see in this frankly not a fantasy chain, a whole bunch of embedded components, and as we talked about with the peanuts before, a whole long list of the tools as well. You can play this parlor game quite a bit, but the fact is this actually goes quite deep, and this is just a simple example we used for illustration. Now, what does it mean as far as the total number goes? You've got this breadth, you've got this depth. Well, if you look at some studies that are done, for example, the one done by Sonatype, they noticed that about 85% of modern applications are compiled from open source components, and the content can be up to 97% in web-based applications. And they found, on average, that there's 460 components within an application. But again, when they looked at some of the web applications, they found 2,000 to 4,000 different components that were put in there. That's a lot of different pieces. Gonzalez, another study, found that over 80% of the applications contained reusable code of this sort. And they said that unique code only represented about 5% of all code. Now, you might look at that, and if you're as much of a nerd as I am, you'll say, wait a second, that's 80 and there's 5. Where's the other 15? Well, there's also some hidden value here, and I know that people in this room are guilty of that hidden value as well because I see you sitting at your laptops. That's cloning. So cloning actually represents more components that are hidden in the supply chain. When you cut and paste different pieces, you are basically taking a component from one piece of software and inserting it into another piece of software. And again, the studies show this out. Again, I just quote some of the studies that are out there. You see 10 or 15% of one piece of software. They took a look at large programs over 1 million lines. 20% of it were cut and pasted code. Without Linux, they found over 100,000 different pieces that are cut and pasted from one part to another. This is throughout the system and represents another piece of code. There have actually been studies done which illustrates the problem with this kind of issue. So a guy named Brumley, who's at CMU as well, helped lead a study that looked at code that's used to manipulate credentials to make sure to set up encryption. Certain set of steps you have to have. Presumably it's all well documented in the documentation. They went through a bunch of applications and found that people usually screwed it up. And they screwed it up in exactly the same way because they copied and pasted some sample that was in Stack Overflow or what have you that was wrong and propagated them throughout. Now, we ourselves have found similar kinds of things with certificate manipulation where people screwed it up. We did a study on looking at Android applications. We found over 1,000 of them just randomly, I won't say casually, it was more systematic than that, and where they did the certificate manipulation wrong. That will turn out to be a bigger issue when we talk about how one finds out whether things are going well or not. Now, the real problem, or I should say the real problem, there's lots of problems, but another issue is a lot of those components are open source, and open source is not secure. And I think you may have had some discussion of this earlier. I know that originally they had been talking about it. Things like Heartbleed and Shell Shock, you probably are aware of. Those were actual exploits that people went after to actually do bad things. But they're not the exception. So there's a study that was done. The purpose of the study, this was from a Black Hat presentation, actually had nothing to do about security and open source. The point of this particular study was to say that all the data that you get from DHS or NIST about how many things are going wrong, whether you look at CVSS scores or CVE scores or CWE things, those are all different measures of the security of different pieces of software. The point of that talk was, don't believe any of it because there's so much more going on that's not being recorded. And they gave 2 examples in where 2 different researchers just said, hey, I wonder what I can find if I go look. And they basically just took a quick glance at one case they were looking at a particular kind of fault, another case, a particular set of modules of software, and they basically just found thousands of problems. And as the one I mentioned before, when we found the certificate issue, we again found well over 1,000 problems. So much so that the organization responsible for tracking it, people who do CWEs and CVEs, MITRE on behalf of DHS, cannot handle them all. So when you look up something there and you don't find it, doesn't mean there isn't a problem. It means they simply could have run out of numbers. They could have run out of time to do it. And we as CERT within the SEI have our own block. We find so many of them. They gave us our own block of numbers as we still run out. So I mean, there's just a lot of these kinds of hidden problems within open source. This is what Sonatype found, and these are things which they can track of components that they are looking at. That over half of JavaScript components have problems, that you see 10% of the downloads have problems, and this is an increasing problem over the last 5 years. Now, I mentioned about the tool chain before, because we say, all right, there's a bug in this module, go fix the bug in Heartbleed or whatever. The tool chain that I mentioned in that previous slide is not hypothetical. In fact, there already have been tools that are out there that people are using that when you build your program with that tool, it inserts bad stuff along the way. Xcode Ghost is one example where that happened, and you can see a whole list of programs that got put out into the public where they had this kind of problem. And it's not the only one, it's perhaps the one that's talked about most, especially since people think of Apple and Xcode Ghost as an Xcode tool. People think of Apple as being especially secure, and yet this is one of the examples where the tool chain itself caused problems in applications that people were working on. Now, it's only going to get worse because when we talk about adding machine learning, you're talking about not just those programs that are going in, but also the data they use. In machine learning programs, and I listed a bunch of them there, all of the old things that were there before still exist. TensorFlow, probably the most popular system used. It has the same buffer overflow problems. It has the same null pointer problems that all the other conventional software has. In addition, these kinds of programs also have mathematical weaknesses in them, which are not obvious to the casual developer working on it, only someone who's really expert in the mathematics of those systems. And again, there's a wide variety of literature there about how these systems can be fooled by knowing what the mathematics are and exploiting it. To build these systems, you need data. You need data to train, and you need data to test. And unfortunately, those two revenues have their own supply chain of how that data is collected, biased or not biased, and how you divide it up into test data and training data. And you see potential issues here already arising. For example, we know that there's a rich supply of deepfakes already out there. In fact, it's specifically built in order to let people try to test their system to see if they can find these deepfakes in order to see whether the system can respond accordingly or not. It turns out they can't. That again, this is a list of various studies done and where they collected pairs of pictures. Some of them were deep fakes. They're the same person, one person, and then projected on someone else. And sometimes they were the same person, just two different pictures of the same person. You can't read all the specific details here, but I'll share you just some of the results that between 50 and 70% of the time it got it right, which means 50 and 30% of the time it got it wrong. That's a huge amount of times of errors that these systems have. So as we're moving forward into these new kinds of systems, the supply chain issue of making sure you have pristine data will start to raise itself as even more importance. So what do you deal with this? So this is what we've been recommending. And again, as I said, we recommend this not only to the Congress, we go to the DHS meetings. They hold meetings on supply chain. NIST has meetings on supply chain. Department of Commerce has meetings on supply chain. And we talk about 4 things that need to be done, which we abbreviate as speedo. You put that in your mind so you walk out of here, probably maybe the only thing you remember of everything I say about the speedo technique of doing this. But it's about supplier, product, distribution, and operations. So if you can get a handle on those 4 things, you have a chance to start improving the supply chain situation. So first, supplier, what does that mean? That means, does the supplier do things that make you believe that they are building secure software? Now, Microsoft has their particular way of doing it. There's lots of ways of doing it. One way to find out is to ask them for an inventory of what they are doing and how it works. There's something called BSIM, Building Security and Maturity Model, which has been widely used to see or at least measure what people are going on. Quick comment on this. Sometimes people misrepresented it as the best practices for development. It's actually representing the most used practices in development, but at least it gives you a way to categorize all the various kinds of ways that are being done. This is done a lot in the IT industry, in the financial industry, the telco industry. They have hundreds and hundreds of companies who have done this already. So it's not something that's unreasonable to try to get suppliers to sign up to do. And whether it's this one or some other one is not as important as getting some evidence that you believe your supplier actually is taking this seriously or not. Personally, I'm not a fan of some of the other ones, which I won't name by name, in where they only talk about process documentation. BSIM says, did you train your guys? Which secure coding standard are you using? We talked about those kinds of things before. Those are specific. You can say, okay, I like MISRA, I like the CERTS coding standard, or whatever one you like. That's different than some of these other standards that say, have they written down a process by which they're going to think about how to do it right? And then the second question is, have they implemented that process? So you can think about a Larson cartoon. Yeah, I wrote down that I do not good things, and I follow that process of not doing good things. You get the gold star, but it doesn't really matter a whole lot. Now, with open source, there's no one for me to give that BSIM questionnaire to and say, can you please fill this out and tell me what you think about your process? So there's some proxy things you can do that people have suggested. There's mixed evidence on how well this actually reflects, but at least it's a start. You can take a look at the history of the project, how long it's been around, who are the committers, things of that sort, if it's popular. If you have more sophisticated committers, if you have more popular components, odds are it's got more real development process behind it, because many times those attract commercial developers that are involved with it. If it's one undergraduate who's doing some hacking in his spare time, you may not want that particular open source component as much. There is a nice one that's been defined called ATOS with their QSOS model that talks about how to define, evaluate, select, and qualify. I'd like to tell you more about that and show you some of their diagrams. Unfortunately, I'll get out on my soapbox here. I can't do that because they mark their particular piece of documentation here as copyleft, for those who know the new licenses. It's not simply an open source license, it's the effective license. And for me to do that, I then have to say that anything that goes on with this presentation has to follow the copyleft copyright as well. We work for the government. If you know, it's government paid for this. That's what the copyright thing says. It says the government can do anything they want with it. Well, the copyleft license doesn't say you can do anything you want with it. You have to follow their rules. So do a search on Atos QoS. There's some interesting stuff there. I can't really put a whole lot more up there at this time. And there's a URL at the bottom again, so I'll try to make it easier for you. OK, next thing. If you got the supplier OK, what about the product itself? Have you any evidence that the product has been evaluated? So I've been in many different companies along my life. We used to get asked for things like reports from different kind of vendors. Even the Army today will ask a vendor, give me the results of Fortify. That's a particular source code analysis tool. Show me what that tool says about your code so I can get some feeling for what the quality of that code is. You can determine what kind of analysis you like, whether you like dynamic, static, interactive ones, whether you like it to be able to contain. We spent a lot of time today, I think throughout the conference, about the use of virtualization as a way to make enclaves that put fences around it. That's the more generic kind of comment called RASP that's being used. Can this thing be put in some kind of system that can be isolated so if I don't trust it, at least I can prevent it from destroying everything else around me? There's a growing body of third parties who will also do this for you if you don't want to actually invest in doing the evaluation yourself, which is typically what needs to happen for open source. You can buy a copy of Fortify, I'm just picking them at random, and take all your open source components and run it through Fortify. It's expensive, it's time consuming, probably not worth it at an individual level, but there are companies who will be able to do this for you. But it's, again, looking at these ratings that are out there for components that are there, doing your local scanning, and most importantly, using centralized distribution. We'll talk a little bit more about centralized distribution in a moment. Another key fact in trying to organize your programs, this goes back to the supply chain rather than supplier. And this is important because most of the time in this discussion, they talk about suppliers. How do I get something from you to me? What you really want to know is all the people going back, how have they done it? And for that, you want something called a software bill of materials, in where you actually can see all the various components that are sitting inside it. And because this accumulates, you get to see everything that comes up through the value tree that's made up of your system. It's even more important because better companies these days are actually taking things out of their inherited components in order to reduce the attack surface of the resulting application. Well, in that case, you don't need to be told there's Linux in here. You need to be told actually what pieces of Linux are in there as just one example of that. And there's work going on to actually legislate this within the Department of through the Department of Commerce. Another thing you need to avoid when you're looking at product is to avoid fragmentation. If you want to use module X, decide which version of module X you can use. Yes, you will have plenty of discussion about, well, that version is better than this version, or it does this, or it does that. However, when you start fragmenting it, you lose track of what you've got and what its particular status is about its quality. And I just use this as an example of the different fragmentations that's gone on with Android. If you had to track all that, you would not be able to make sure that you had any kind of confidence in the security of what you've got. Talk a little bit about distribution, getting it from point A to point B. It's very easy to break things along the distribution channel. I'll give you some examples in a moment. But how do you make sure that as you get software from point A to point B, that you somehow have a handle on that? Going back to what I mentioned before, very important in many organizations is have a single point of distribution to the internal development teams. Because it's open source in some companies, usually medium to smaller companies, any developer can go out and grab any module if they want. But as a result, when you build your product, you have no idea where those individual modules came from. You may have 5 different versions of a particular module, and no one can reconstruct what it is or where the quality came from. So instead, you need to have some central point of distribution. That internal point will then make a decision. I'm going to take version 3 of that module, and everyone will use it. Everyone will come to them, and they will then be able to keep track of everywhere that particular module is. And the second one is, I'll be very simplistic here, no cloning. Now, we can try to say, guys, don't copy and paste. Odds are that you won't be able to enforce that at gross level, but at least have that philosophy involved so that people start to realize what the implications are as what they're doing it. If you go, there's actually a fair amount of literature on this. If you go into it, there's actually a lot more subtleties about. They have like 4 different kinds of cutting and pasting. They have observed in practice, and some of them they result in errors, and some of them don't result in errors. We don't have time to go down into that level of detail. So for now, I'll leave it the thought in your head of just outright ban cloning. If it's that important that you need to have it in lots of places, make a module of it. This is some examples of corruptions that happen in the supply chain. I won't dwell on the top one. This is some from Microsoft NT products, and where they snuck some things onto the media as they were going out. Very benign. That's because Microsoft is a benign company in this kind of regard. In other cases, Deloitte's not so benign. They were showing here how to take a calculator and just make it into malware on the fly. This is a demonstration at a particular conference, so if you actually want to see how to build your own malware, you can run that video, and they'll show you how to do it step by step. Again, these are not hypothetical. There are lots of examples in where the distribution sites have infected the programs. In some cases, not necessarily the Google store, but other places, up to 50% of the applications on there were in fact other applications that were in rebuilt or attached with other kinds of malware. The last one, the trickiest one, is what I call operational resistance. When people build modules, they usually build it against a collection of assumptions, and a lot of that has been discussed today. They built different kinds of facilities, and they did that assuming a particular environment in which they're going to be used. Unfortunately, as that environment changes, those assumptions change but don't always get tracked. So a module which was safe before was not safe anymore. To tell you quickly, I'll give you some examples. Before we do that, how can you try to mitigate it? One is you maintain an inventory of all your components, so you know at least where everything is, and you have some sort of patching and other way to track how to keep it up to date. Now, what's some examples of how this has happened, just so you can appreciate some of the subtleties that go on here. So there was a steel furnace that was attacked in Germany a couple of years ago. I don't know, again, how much people read about this. The SCADA system. You can imagine the person who wrote the SCADA system said, I'm going to run these furnaces. Who's going to talk to the system? Well, it's going to be the guy on the factory floor who hits the controls to say to move the furnaces around. I can trust that guy on the floor. He's not going to do anything silly. But of course, someone said, gee, the floor system, I want to know what's going on in my company. They connect that to the ERP system, so they have a good view of the inventory. And someone says, hey, we want to know whether we can quote an order or not. So they attach it to the CRM system, which connects to the ERP system, which connects to the SCADA system, and said, hey, I know this bucket of steel is going to come out. And they say, let our customers see what the status of their order is. So they put a web interface onto it, which talks to the ERP system, talks to the CRM to the ERP, to the SCADA system, and then a bad guy comes in, and he followed all that path down and destroyed the steel furnaces. Why? Because the guy who did the SCADA work never envisioned that kind of path happening. I don't think because he was an idiot. Another example that you may have heard about is the Jeep. That was talked about a lot. And I don't know the individuals involved. They didn't talk to the programmers at Fiat Chrysler. But I'm assuming the guy who wrote the software to turn on the brakes assumed that the only message to turn on the brakes would come from someone pushing the brake pedal. And so there was no need to write software as part of turning on the brakes to say, where did this message come from? It came from the guy pushing the brake pedal. To telescope the story, same thing kind of happened. So the CAN bus got added into the display system got added to the entertainment system got connected to the internet, and lo and behold, you have the Wired article that documented the demonstration of going all the way in through the system, through the path, and turning on the brakes. Why? The module to control the brakes was developed against a different set of assumptions. As things evolve, it turns out this is a pattern. A study done by Sherry Clark pointed out that one of the 2 biggest reasons by which vulnerabilities are introduced into systems is when modules are reused in new contexts. And as a result, it's something to be aware of as you start to interconnect systems to understand what those problems are. This one, I don't have a real good, easy suggestion for, because it's very hard to know what the assumptions are of those modules sitting in another place. Who knew? Do you really blame QNX the guys at BlackBerry say, well, I didn't think I was going to have to worry about the brake system, so why should have I put in a check for that? No one would have put those 2 together, but that's what happened. The only thing I can suggest is to weigh carefully the risks versus the cost of implementing defense in depth. The guy building the brake could have added in code to say, is this only coming from the brake pedal? And that might have been able to mitigate this particular issue. However, that's extra code, it's extra cost, it's extra amount of energy. It's all sorts of things that the engineers are trying to optimize out as they build these kinds of systems. I'm suggesting make very conscientious choices about that rather than simply letting it happen. Understand that that's a risk. I've told you about a whole bunch of things. There are lots of groups looking to try to address this. DHS is one example, the Department of Commerce is another example, and this is another example. Obviously, we're involved with this as well. As I mentioned earlier, Congress is trying to figure out what kind of regulations might make sense here. So it's something which affects us more and more. We are trying to make it better, and I hope today just to give you some sensitivity about what this issue is and how it might affect some of your thinking as you start to download everything from GitHub and start throwing it into various kinds of software. And with that, yes, sir.
Yeah, on your Canvas things, work was done.
Yeah, with Chris. Chris and I did a webinar on this.
On the CAN bus thing, some work was done a little while ago.
Yeah.
And it was discovered that you actually can't secure the CAN bus, so there's an effort going on right now in the auto industry to throw it out and replace it with a bus that can be secure. And it wasn't just Jeep, it was everybody had that issue.
So there's a lot more technical discussion that can go on there or not. You're right, there's certain elements of the CAN bus protocol, but there's also, if you look at some of the things I think is being done by Audi, don't hold me to that detail, but I think it's one of the German companies, then where they're actually separating the buses out so that there is no connection between the buses.
You should never have a control bus connected to an entertainment bus of any kind.
I'm not saying you should. You don't have to convince me. I'm using that as an example of how that connection gets made and why people need to be sensitive to that. So, yeah.
It's worse than that. We built controllers for nuclear reactors that were built on a certain operating system. And they were built with the assumption that the controlling function of the nuclear reactor was independent and never on the internet. In comes a service person who has to fix the machine. What does he do? He runs a cable from the control system that controls the reactor to something that's on the internet. Guess what? It got infected. Fortunately, it could have been really bad.
Target is another example. I'll give you examples from the DoD. I actually have a deck of examples. I just threw two of them here. I've got dozens and dozens of them. So we're on the same page.
What could possibly go wrong by connecting to the internet? I mean, that's 3 more cents I could save. No, serious question, no. So if I understood that correctly, then the only way we're evaluating these software packages then is by feelings, by looking at code. Are you familiar or tracking any academic research that tries to find more rigorous ways to look at it where you can assess the quality of it from a third-party perspective?
So most of the assessments so there's 2 answers. One is technical, one's process. On the technical side, you're right, it's getting reports from, in the case like the Army uses, from Fortify, or whichever collection of tools that you want to try to measure some kind of quality. The other one, as it's mentioned, is process, which is the producer of the software at least cognizant and implementing things that ought to result in better software, whether they use the Microsoft model or their other models. Putting some process in place turns out to have a lot of value. That the hygiene of software out there is so poor that you could actually make a big difference just by doing some basic things.
So we're measuring the Dunning-Kruger effect of our software developers.
Don't know. No comment.
So you mentioned part of the problem with CVEs not really scaling because there's just more bugs than we can keep track of. Do you have any thoughts on how to improve that so we can at least know what bugs are in the crappy old software we're plugging into things?
Money? Seriously, I mean, DHS is the amount of money that MITRE has been given in order to do this has not scaled with the need, and most of the people working on this have recognized this. I think the bigger issue that they're focused on, however, do you know what CVSS is? So, for those who don't, one is what's the problem? The other one is how bad is the problem? Because presumably you like to only look at really bad problems, because you don't have resources to look at everything. Turns out that score doesn't seem to correlate well with actual impact. And so I think more attention is being placed on how to evaluate how bad something is rather than collecting more and more of them. Because there's so many that if we can figure out which are the really bad ones, at least we can focus some attention on fixing those. But that seems to be the priority on the investment of the funding here.
I think my question is mostly, when you're highlighting a throttle in a process that you have, is that failing silently, or in what way are we making that information exposed to the parties that rely on it, would consume it, could potentially contribute resources to operate on it? I think that's the bigger concern that I would voice here.
So part of what you're talking about, I believe, is a political issue rather than a technical issue. And for example, take that software bill of materials that I alluded to earlier. We've been involved in making runs of that for close to a decade, and lots of software vendors very much were against that. The official reason is that that would show their competitors, that would reveal some competitive advantage there, including module X their competitor doesn't have. That's what they say. But as a result, you don't know what's in there, and therefore you don't have any ability to even connect up some of the dots, let alone then start assigning who should be responsible for fixing dots that have turned into colors that they shouldn't turn into. So as I said, I think there may be a more political issue of liability as to who has to fix things rather than a technical issue of being able to identify them.
That's fair in regards to the bill of materials consideration. I think my comment was more directed towards highlighting that NIST or CVSS are currently overburdened, right? If they've advertised themselves as a consolidation and consumer of this data, right? How are they exposing the data that they're not able to process?
It falls on the floor. I mean, literally. As I said, we have lots of them that we just really can't report. There's no one at the other end of the wire to take the report.
I see.
So about the how do we evaluate our open source components and what goes into them and have some measure of quality of them besides CVs? The Core Infrastructure Initiative, which is I think a Linux Foundation thing now, came out with a set of criteria for best practices that you can follow that they suggest open source projects should follow, as well as like a little badge you can put on GitHub projects for how much of these do you follow. And it ranges from everything from, do you have like a semantic versioning number scheme that actually is meaningful to humans? Do you have a bug reporting process that's clear? Do you have a vulnerability reporting process that's clear? Do you, are your builds reproducible? Do you have things like compiler stuff? Like the whole long list of ranging all kinds of categories.
Yeah. So the same spirit as BSIM, but yeah. I've seen it, yeah.
Cool.
But the question is...
No, I just wanted to make the room aware of that.
Yes, and Open Group has something as well. It's more process-oriented. There's a variety of attempts to make it better.
Yeah, so it's not that nobody cares and no one's addressing this problem. There are ongoing things.
What percentage of the inbound flow would you say is unaddressed?
I don't know. I don't know how many are being dropped on the floor, I think was what you're asking.
Yeah.
And if I looked recently, I think they have 150,000 on file now. Mm-hmm. But to give a comparison, it's not a completely fair comparison. Certainly Symantec and other virus companies, and we as well have over, well over 1.5 billion examples of bad things out there. So they found 150,000 of them. So there's probably more.
You mentioned CVSS scores not keeping up with actual or not reflecting actual vulnerabilities. Do you have studies or anything that show that? Maybe feedback into that community to address those?
So we have some information on that, and we have, again, one of the groups at the SEI is actively involved in trying to help improve that. So yes, there have been some work done. To call it a study, I think might be too rigorous of a word, but there has been work done, as well as proposals as to how to make it better. What kinds of things should you measure, and how might you do it? Frankly, one of the first things they're doing, back to the question you had before, was trying to come up with what may be fairly simple, a workflow process of how one finds and scores these kinds of things. It turns out, as you might imagine, at different stages in doing these analysis, you need different skills and different numbers of people. Right now, it's kind of arbitrary as to how many people are doing which part of which stage, and therefore, we're not even be using the resources we have optimally. And so one piece of work is just how can we take what we have and just do it a lot better with the right people at the right place.
I have a comment on the CVSS questions as well. If you go to first.org, the CVSS board is actually taking requests, feedback, and input for shaping the future of CVSS scoring. Right now, it's currently on version 3.1. 4.0 will be coming out in the coming years. Usually takes quite a while to get through the approval process. But if you do have feedback or suggestions, I recommend you go there and provide those.
Yeah, so we're part of that, and as suggested, other people are more than welcome to add in as well. The CWEs were also just had a major revisiting as well. So it's not that this is static, but nevertheless, in all of those kinds of characterizations, they're less than what we really need to be practical. It's a starting point. It's better than not having any insight whatsoever.
Are you aware of efforts to track relationships between bugs across the supply chain? After the fact, almost like...
Well, so the study I mentioned from Sandy Clark did a retrospective of software histories and where both defects and vulnerabilities emerged and when they emerged and why they emerged. So that's the most comprehensive study that I'm aware of on that particular topic.
Okay, but not a live database, like not an ongoing analytics.
I don't know of any, no.
Okay, because there's some effort to do that within the Linux kernel in the continuous integration work to do structured analysis of the patches and find patterns.
And in fact, some of the studies that I referred about the cut and paste out of Linux and maybe part of that whole process is trying to see what some of the history was and where the different pieces came from, and at the same time figure out what started to motivate some of them was there's a piece of code, there was a bug in it, we found it, we believe it's elsewhere. Where else can we go fix this bug in the million lines of code that we've got here? Let's go find them and fix them all at once. So a lot of that work came out of that particular goal.
Yeah. So I mean, one of the things we see with hardware-based security is by the time we find the problem, it's just too late to fix. And also, even firmware, the firmware engineers are disbanded by the time the problem is found. So you got to get it much earlier in the cycle. And also, you have to get it before it becomes an official CVE, because at that point, it's a political or a financial or a legal liability. So really, you want to track these dependency chains almost at the patch level in open source, way, way earlier. And it has to be live, like across the ecosystem.
And so we're taking baby steps. Before you can even track it, you have to acknowledge its existence, which is why we push so hard on this bill of materials.
And then on the bill of materials, is there a unified namespace for the identities of the contributors and organizations?
So if you go to the report in the study that's in the deck, there's actually several different versions that are being considered about what should be contained, how it should be contained, how it should be maintained and distributed. So the exact details are currently under debate. That's part of what that standards process is going through. But at least we're talking about what to include, not if to include.
So just a question. It seemed like a lot of what you've been talking about is software. Are you aware of any studies for like hardware components or firmware components at the embedded level?
I am not. That's not to say that they don't exist, but I'm not. Go ahead.
You want the mic?
The cyber independent testing lab, CITL, Mudge runs it. It's DARPA funded, and they've been doing work. They started with router firmware and been just looking at things like toolchain reuse, how that affects binary hardening. And so they are making baby steps on that. But yes, there is work being done at the firmware level, and that's expanding to other IoT devices as well, outside of just routers and then other pieces of firmware as well. So CITL is something to look into for that.
Okay, thank you very much.